Hi, I'm Troy Ruth, CEO of Ruths.ai. I'm really excited to have this opportunity to introduce you to Dr. Mark Zoback, our technical advisor with a focus on geomechanics. We're really excited to bring together geomechanics and machine learning to help better understand our development strategies for unconventional resources.
I think there's tremendous power in the machine learning, obviously. Building tools for people to use the data they have and to draw the right conclusions. And what I'm trying to do is define the geomechanical principles that guide that search process. And I think those two things coming together is going to be extremely powerful and very impactful. We can't separate the power of machine learning from the power of geology and physics and reservoir engineering. They're all integrated, and when you use them in an integrated way, they turn into a very powerful tool. And as you said, 200,000 wells is a tremendous database. There's maybe 10,000 wells are going to be drilled this year, and every one of them is an opportunity to gain new insight and understanding, and then to as we think we learn something new, we test that understanding. We look for the fingerprints of that issue in the data that already exists, and then suddenly your experiment is confirmed, and you're ready to run with it. We're at a really exciting time. Industry needs these advancements. It's a very critical time in the industry, and I think the approach we're taking has every chance for success.
And to break that down even more, we have three major themes of the work that we're approaching. The first is how do you optimize stack pay development and vertical frac containment.
Right.
The second is what are the factors that contribute to generating good near wellbore complexity and complexity around the fractures. And then the third is handling well spacing and parent-child effects.
Every company that's out there is struggling with every one of those problems, or one problem is dominating everything they do. The well spacing issue is particularly problematic because when you're, in the early days, you don't know if wells are too close or too far apart.
Right.
And in fact, if you're only learning that over time, you're making decisions about an optimal well spacing on the basis of very incomplete information, and you're likely to make the wrong decision. You have to make a decision, but if you're just waiting to see what happens, you actually won't know for a couple of years whether you made the right decision or the wrong decision. We have to approach that question in a fundamentally different way. The same thing is true about the exploitation of stack pay and the way in which hydraulic fractures grow and are affected by the variations of stress from layer to layer. In most cases, you can't do anything about that. Right. You can't change how what the stress in the earth happens to be, but you can adapt to it. You have things you can change during the hydraulic fracturing process, where you put your well and how you actually carry out the hydraulic fracturing in the context of the geologic setting. There are reasons for this, and there are reasons why some completion practices work better in some places and not as well in other places. And so by connecting all these dots, we suddenly have a totally new understanding of what's been happening out there, and it's on the basis of that understanding that I think we'll make real progress.